So I want to say that for the purpose of the talk, I'm going to be in the role of the mobile engineer, and hopefully you can relate to some of the things presented here. So let's dive right in. First of all, a quick peek at the agenda. We're going to look at why is mobile a crucial domain, looking a bit at the mobile ecosystem, but also trying to bust some myths. For example, the myth of cross-platform. That looks always promising, right? Or what happens once we had our first release out? Or what is mole actually in mobile? And hoping to tackle those store-related anxieties. We're all scared a bit of the store updates. So let's see, why is mobile a crucial domain? Well, mobile has become a core part of our lives, right? We are so engaged in the mobile interaction to the extent that sometimes we don't even pay attention to our surroundings, right? So careful there, don't let those apps sleep you up, so to speak. So let's see, actually there are 6.8 billion users of smartphones out of the 8 total billion users, billion people worldwide. And we tend to spend about 5 to 6 hours daily on our screens, on our small screens. But let's face it, I'm pretty sure that everyone in the room actually spends more time than this average. And also, 99.2% of these users experience various degrees of nomophobia. What's this nomophobia? Well, it's a new kind of phobia. It's not really well documented, but it's short for fear of being without a mobile phone. It's not just the fear of not being able to be contacted, but it's the fear of missing out on those digital interactions. So I'm not going to dive into, what is, who's responsible for this, or what are the social implications. But I'm going to take a look at why this happens. Well, because in terms of apps, there are actually a lot of various apps out there. Between them, the Apple Store and the Google Play Store total about 5.3 million apps, and that is after they have been doing some kind of cleansing on the stores. And you'd expect most of these to be gaming apps, but no, actually 80% of the apps are not gaming apps. And this is data according to Q2 of 2023. So there are quite a lot of choices there. Plus, the stores are very competitive. They push apps. They create shops. They make us sort of install these apps, right? But when you talk about mobile, are we talking about only phones and tablets? Well, yes, but also TVs, watches, and basically all sorts of compatible environments. Right now, you can basically run a mobile app in Chrome OS, in Mac OS, in Vision OS. But also, mobile has become the main means of interaction with other things as well, such as wearables, from fitness bracelets to, let's say, any other device that's smart enough to be carried on with us. Immersive experience are also tackled on mobile. Also, ambient surfaces, voice assistants, but also all sorts of IoT and automotive applications. So I think it's pretty clear we can't have that equality sign right there. But another thing to mention here is it's actually for the first time in a decade where new smartphones shipments have declined with 6%. So this means for the mobile engineering space that there will be an immediate need to support more long-term older devices, legacy devices, and also to target those changing patterns in customer behaviors, because some would move to the mid to high-end devices, but the most of the population will still have some low-end devices. So let's see what's actually behind the scene in the mobile ecosystem, because I hear this really often, that mobile development is just easy, right? What could it be? It's just rendering a UI on a small screen, right? You could do web for that. But is this actually true? Let's see. So I believe that there's more than meets the eye in mobile. And I think as users, when we see UI, we think just UI. And I like to call this a form of UI-based tunnel vision, right? But the UI is just the tip of the iceberg here. And I think we need to see what happens below this tip. And a lot of things happens, right? We need to support those different platforms and how we interact with them. We need to support those different hardware interaction accelerators. Plus, there are there's a intersection between mobile and a lot of other domains like IoT, right? We intersect with various IoT devices like Bluetooth devices, even with the AI, right? Because ML has come to mobile. It's not just for inference, it's also for training. That's possible as well. Plus payments, the security layer, and a lot of other things. So when we start to consider how we are going to develop a mobile app, and it's time to make some choices, there are basically two main choices to be taken: the platform approach and the architectural style. So when it comes to the platform approach, we could start with a fully native tech stack, right? Where we would employ native iOS using Swift or native Android using Kotlin. And yes, this would give us the best performance, but it would also give us two totally separate code bases that we would have to align. Then there's the cross-platform choice, where there are a lot of, let's say, promising choices out there. Some have known performance issues, but developers are always on the watch out on what happens here. And there's also, let's say, what I call the lazy approach, when you just do a web app, right? Why not a mobile website or a progressive web app? Where, because most companies, when they like to position themselves as a brand, they require a store presence. And so website doesn't really generate trust on mobile. These are, let's say, the more pure approach, but the reality is that here we will be seeing more and more mixed approaches. It's time for our next choice, the architectural choice. So if we go back to the basics, right, things appear to be simple because we have three layers: the data, domain, and the presentation, right? And another, let's say, pattern that has been reinterpreted on mobile, it's Uncle Bob's clean architecture. So when it comes to where, you want to keep the effects and the UI totally separate, have a flow of data coming from the outside to the inside. However, when it comes to delivery, there are a lot of options on what type of architecture should it pick. So we can see here 10 of them, let's say, most popular in the past years, right? I guess the popularity of all of these architectures has been influenced by the way the underlying platforms, so the iOS and the Android APIs and the SDKs are being written. For example, MVVM is now on top of everyone's mind when it comes for architecture, while it's actually the default architecture on iOS right now with Swift UI. It has become the default, but it's also popular on Android. But that's not the only option. Let's remember that a while ago, Apple was massively pushing one architecture that was always mentioned as an anti-pattern, the model view controller, or if we remember the jokes, that was also called the massive view controller. So I guess we should remember that architecture is a trade-off, and my advice is when we need to make a choice, let's actually take a look at a quote that I found a little bit inspiring. So this is actually a quote from Barbara Liskov, which is a known computer scientist and also author of the Liskov substitution principle. I think behind the scenes what happens here is that we need to employ some kind of critical and logical thinking when we make architectural and platform choices. So that's why I want to propose that when we look at the mobile architecture, we should try to actually have three main attributes: clean, reactive, and modular. So why clean? Because it's going to give us the best decoupling and different layers, also testability and maintainability. While reactive? Well, because in mobile, we actually require more than just an event-driven architecture. We want to have the means to respond to various events coming from sensors, from the users, or from other external devices. And a reactive architecture would give us the best means to do this. And why modular? Because it gives the best flexibility and the opportunity for growth. But you know what they say about principles without context? It's just added complexity, right? So everything needs to be binded together by the context. The context being the type of the mobile product that you are trying to build, your team size, the knowledge inside the team. Those are also very important. Now I want to deep dive into the myth of cross-platform, right? Because cross-platform as an approach in mobile seems really promising. It has this mirage of being a one size that fits all. But let's see if this can always apply. So it's often the question in mobile to cross or not to cross platform. So we see this as a binary choice really often, right? On one hand of the, let's say, the road, we have the fully native approach. On the other hand, we have the fully cross-platform. But in reality, most of the apps out there will be a native app with a mini cross-platform or web component, or a cross-platform which is going to have some mini native components. So let's consider that we have done, our initial research, and we are going to start a mobile project with the cross-platform architecture. Well, there are obviously advantages, right? We're going to obtain feature parity, only have one code base, manage to, align releases. Plus, if we go with a React Native approach, we're going to develop into, programming languages that have quite a good pool of developers out there, such as JavaScript or TypeScript, right? Sure, there's the bridging part, but most people tend to look at the bridging part as a black box. So, but it shouldn't be the case, because the bridging part, it's a major drawback on cross-platform. Behind the scenes, the bridging here, it's actually a pattern of async messages that are passing between the native and JavaScript threads. And they either use, JSON or serialization, depending on the rendering engine behind the scenes, but these messages are having an impact on performance. Imagine they can't even get canceled. You have to process all of those messages. So please, let's not look at the bridging as a black box. So what could go wrong here, right, with the cross-platform approach? Well, a bunch of things. You either start ignoring platform differences. We don't care about them. We all want to consider that Apple and Android platforms are like two friends sitting on the bench besides their differences, but that's not the case. Or we realize the differences, and then our code starts to get littered with all sorts of conditional checks. If this is iOS, then do this. If this is Android, then do the other thing. Then we tend to extensively rely on pre-built modules, right? Someone else could do the bridging to, those Bluetooth services for us. Or, just use yarn magic. Pretty soon we realize that fast is going to compromise on the quality, and it's not quite the native look and feel. And yeah, there are a bunch of disruptive events out there that can break things. For example, new OS updates or new frameworks being exposed. And new engines are therefore still playing catch up with the native. So at some point, we realized that once a cross-platform project starts growing or new features are being added, there are performance issues that need to be addressed immediately. And performance issues usually happen when you start to add features that are, let's say, more data processing intensive, or that require some sort of specialized integration, such as a payment, an IoT, or an ML integration. So the first idea that we have after several releases and iterations, we would address this by starting to create some native modules. Sure, they're the best way to bridge the gap between the native side and the cross-platform side. So let's imagine we start to create some native modules for React Native, one per each of the platform, right? Then we'll need to align those APIs, start bridging them, start packaging. We're gonna need to add our own suites of tests, both for unit and integration to each of these layers, and to make sure that we are doing the right things, let's also attach one companion app to, the iOS native platform, the Android native platform, the NPM package, and also potentially an example app to before publishing the package. So let's recap a bit what happened here. We again managed to add multiple layers of integration, which obviously made bugs harder to track, right? Where would that bug be? It could be in the native side, right? Or somewhere else on the bridging side. We now have several separate code bases, and while developing these, we have encountered some limitations on the bridging. Some are really well known, like for example for performance, while others are less known. For example, there's quite a huge issue with numerical types passing, right? And take, for example, iOS, right? It's normal because when we build such a thing, we actually need to pass through 4 programming languages with React Native right now. So we still need to use the so-called legacy Objective-C, still need to use Swift, still need to use JavaScript, and still need to use TypeScript. So, yeah. And surprise, actually, native modules are getting deprecated in the new React Native architecture. They're getting deprecated to Turbo native modules and Fabric modules, which will require us to write C++ code. So one additional programming language added to our pool. And I often get this question, but how about Flutter? Or are there any other promising cross-platforms out there? Well, Flutter is slightly better in the way it treats the bridging side. Still, its engines are still playing catch-up. I have my eyes, for example, on Flutter impellers. Hopefully, it will get soon enough better on Android, and perhaps it would be more promising. So I guess one could not help wonder, could this have been native all along? Well, yes, if we can assume the development cost. So my advice for this one is when we decide to cross or not to cross platform, we need to carefully consider those platform limitations. Most of these are really well known and they're actually documented, right? There are lots of blogs out there about them. So please make informed decisions, not just the cost of initial development. That's a factor indeed, but let's think more long term. Native development is still the key. And even if you don't start native, consider that native specialized skills will still be required for the successful of an app. So use those. And most importantly, remember this is a journey. Once you start an app, it will need to evolve, and rarely things will stay the way they are. Which actually brings us to my next topic, which is what should happen once we have our app published in its respective stores, right? Should we just lean back and relax, enjoy this first release, or do we need to, have some sort of strategies and evolve with each new release? So once it's published, this could happen, right? This is actually a snapshot from App Store's changelog about a very popular and massively adopted app. We can see here some average ratings, reviews. Things are not looking that good, right? From the version history, we see the app is in a bit of a bad state with a lot of bug fixes and improvement. It looks like they're just trying to, patch things up. So it's pretty clear we can't lean back and relax. But on the other hand, they should actually have a better copywriter. I mean, who even puts that in the changelog? It looks like the developers did the changelog as well. So let's see. Once a mobile app is published, we are going to obtain data, and we're going to have this kind of disruptiveness. So users are going to start reviews, sending feedback. Their usage patterns may be completely unpredictable from what we initially designed the app for, right? Hopefully we have the monitoring and the analytical data to see what's going on, look at the performance of the app, the usage metrics. Then we need to deal with versioning, because in mobile, multiple versions can live at the same time in the stores, right? And at some point, feature parity may not even be possible. Then there's the Apple and Google stores, which are competitive environments. They have tops. Plus, competitors are also publishing apps out there as well. Then there's the mobile OSs and the question whether should we support this new OS. When do we adopt it? Do we adopt it in beta a little bit later? When we actually drop support for devices, right? We need to make sure that legacy support is also maintained. Then there are the phone vendors, which are also, having new models, and they can be disruptive, right? Imagine, for example, foldable phones, or right now the dynamic island on iPhone, right? And then there's the ever-changing tech landscape, where in mobile we have seen a lot of changes, including, having to move massively large code bases to a completely new different programming language. For example, from Objective-C to Swift, or from Java to Kotlin. Then there are new paradigms that need to be adapted, for example, coroutines, or the move from imperative to declarative UI. And there's, in the end, the developer experience that needs to be supported, right? Because no one, in the end, would want to work in such a fast-paced environment on a legacy code base, right? So it's pretty clear that legacy has a tendency to creep really quickly on mobile. And so what do we do about it? Well, if this was like another domain, we'd probably have a more structured way to go about things, right? But what if we could define a sort of, let's say, framework on how to tackle the internal and the external disruptive factors? Let's say this could be entitled The 6 Airs of Mobile Evolution, right? And I have structured this into refine, retrofit, revamp, re-engineer, re-platform, and redefine. And I want to go really quickly over these. Let's first start with refine. So to refine usually starts with the lightest changes to adjust the user's feedback and business needs. It's about refining the user experience, right? Also optimizing resources and metrics in the process. It's actually the one that it's more close to, business as usual and maintenance on a mobile app. Then we have retrofit. This is when we respond to disruptive events of various levels. For example, adopting new OSs or new phones. Or by contrary, the need to drop new features, new OS support, or new and I also included here adapting for any new integrations, for example, with external devices or new additional sensors added on the phone. Then we have revamp. Revamp, it's all about refreshing that UI UX with adding new interaction, and it's usually triggered by, branding or new design rules or introducing design tokens. And as mobile developers, we don't usually leave things here. Once we touch on the UI UX layer, we usually tend to go a little bit deeper and also touch on the tech stack. Then we have re-engineer. This is usually starting a mix between re-architecture and rewrite. We are going to repurpose and modernize the architecture, enforce those three attributes, the clean, the reactive, and the modular, but remain within the same platform constraints. So if we went initially with a native solution, we would enhance those platform initial principles. Similarly for cross-platform. So it's staying within the boundaries of your initial platform decision. Then we have re-platform. This happens when the initial platform decision no longer supports the growth or the business needs of the app. So we are seeing here the conversion of cross-native to back to native, or vice versa, or moving as much of the business logic of the app outside of the app, right? And then we have redefine. Redefine, it's completely repurposing and evolving the mobile app into a completely new product. It may involve splitting your app into several products, or by the contrary, we have several applications that we want to unite in a larger ecosystem of apps. And for this one, we need to be really careful and to prepare the customer migrations. So hopefully now, when we have seen the level of changes that we need to do with each and every release, we should be able not to, just patch things up with every update, but have those decision points when we need to make, larger changes. Because in mobile, actually, apps can have like really long lifetimes in the stores. I know of apps that have been around there from the start, and they haven't moved. They have been, either piling up release over release or completely doing a re-scratch, but they have remained within the same containment of the app, right? And so they needed to do customer migration. They needed to majorly evolve over time. And this brings me to this myth that I'm hearing. Mobile, it's small. And sure, yeah, we can start with a small beginnings, right? A small team, perhaps one app, one release, but it soon could go to something more, right? I always like to say that there's never one app, let's face it. You rarely can ignore those platform differences. So soon enough, you start to, evolve from one app to multiple apps, or to many additional external integrations. So you will have to scale up to support multiple streams of work. And soon enough, why not? You could even grow into a super app, right? Well, super app is a trend that has been mentioned by Gartner in 2022 as one of the top 10 trends to watch in 2023. This is not their definition. This is actually my interpretation of what a super app could mean on mobile. So it's going to offer multiple products, features, integration. It's going to be combined with branding, distributed on many channels, platforms, and it often goes beyond mobile. And it could be like a vertical super app. For example, if we refer to the payment and financial industry, it could be covering the whole set of integrations into that vertical. It could go into something more horizontal and include multiple other services. But what can we do to actually support the growth from the small beginnings to the super app? Well, my advice on how to support the growth and scaling through a super app is to employ these two main principles: mobile modularity and start thinking with an SDK mindset. So mobile modularity would be all about, if you have a mobile monolith, let's start breaking it right now. Or start with mobile modularity from the get-go. This will massively improve, the quality of the delivered apps, but also the experience of working in them. And it will give you the best growth opportunities. And also the SDK mindset. This also prioritizes a little bit the developer experience, and it's going to put you in a mindset where you write things as, just not including them into one app. You are going to have other consumers of your code. For example, within your organization, somebody else is going to use your SDK, or outside even, if you decide to, publish it as an open source or closed source. And you need to start thinking backward and forward compatibility. You need to start thinking about now overexposure, and it's scalable and future-proofing. And yes, the form it could take, it could be something completely different, like a closed or an open framework, a AAR, or a dynamic feature. It doesn't really matter. The principles will hold for each of these forms. So let's take a look at the initial mobile modularity approach. So sometimes we tend to, validate this sort of like equation. Can a mobile app be just the sum of this feature or something totally different? And we start, building these core modules. It could be something for networking to interact with your API services, something for configuration, for UI widgets, or something, to deal with the engagement, like what do we do with deep links or push notifications. And then there's the more specialized category of data modules, which usually deal with repositories, syncing to and from external data sources, entities. You've got to build like a mini database inside there and map your entities. And then there are the future modules, which usually, start getting built as a sum or intersection perhaps of data modules and core modules. And on top of this, we have the app modules, usually grouping multiple feature modules. But what's actually missing from the picture? Anyone want to add some things that are missing? No? Right, it's the hard parts, right? So we're not seeing the dependencies here, right? We're not seeing the level of abstraction, right? We're not seeing the different life cycles and how we distribute and publish all of these frameworks, right? And feature modules. So now, if we were to add just a little bit of those, right, we now start to see the dependencies, and it's clear that we need to do a sort of, let's say, domain-driven design to also define the boundaries here on the mobile side as well, right? We want to be sure that we have the best dependencies and abstractions being implemented. Then we need to also validate things with a strong set of tests, using abstractions, using dependency inversion, but also adding companion apps, right? And companion apps on mobile don't get added just for, modules that have a UI. No, they get added for other modules as well. So pretty soon we'll see that a mobile module is starting to have like its own separate lifecycle, code base, or even separate team, right? So we need to be extra careful on how to handle this. So I want to also go over Why are mobile app updates scary, right? Or can we control the behavior of the whole mobile app without requiring an update, or are there limitations? So imagine we were to do a sort of an interview with a mobile developer. If we were to ask, what are your hopes and expectations, and not from life, just from the mobile ecosystem itself, what do you think would be at the top of their mind? Anyone? No? All right. I would say at the top of my mind it would be instant deployment, but also probably a staging environment, or a better definition of the staging environment would go second. How about biggest fear? This one is easy. Anyone? Fear of rejection, store rejection. And how about your most prominent personality trait? I would say it's being cautious. Why? Because usually bugs in the mobile environment were such a big thing because of the traditionally really long wait times to actually deploy into the production. And by deploying into production in mobile, we understand actually getting from the initial submission process where you have the release candidate that you have tested, validated, and putting it into the hands of the users. And this submission process requires you to go through, sometimes even a manual validation of the store rules. It could be faster on Android. It is usually quite slow on iOS. It even took a week traditionally, right? Things have slightly improved right now, and it's probably a matter of hours or even minutes. But still, mobile devs have, developed this extra cautious and, taking care that your code is really well tested, doesn't really have bugs, and you have a really confident release candidate to put to the submission system. So when navigating mobile updates, what we want to do is actually have a way to remotely control the behavior of the app without having to do that new release, so without having to do a new code update, but also having a way to actually push those updates, right? Because they are sometimes required. So it's obvious, for the remote control, we can use various API services, such as REST, GraphQL, an asset management system, or an interacting with a remote DB store, but also a configuration service, which will allow us to actually change the behavior of the mobile app remotely without having to do a release. For example, here we just changed the color, but we kept the same version, right? So this should actually offer us the way to also do A/B testing, group users, do some sort of UI-driven API, or introduce rule engines, right? And then for pushing updates, because we need to do something about that critical production bug. Hey, it happens. Or, we need to get that new feature shipped really quickly into the hands of our users. And for this, we could go the store way, the submission way, or the OTA or code push way. And we are basically, with pushing updates, we are going to push a new version, as we have seen here. So what can go wrong here? Well, a bunch of scenarios could break things, like offline mode. What happens then? Low connectivity, right? Downtime on these services, or the long wait time on the submission process. So my advice, always be prepared for the unexpected on mobile, both on the services side and on the application side. And this would give us the best ways to, deal with those corner cases, which are actually the normal mobile, right? So I like to say that actually there should be just one side, not the services side and the application side. And we start with, let's avoid doing siloed work, especially on mobile API design and delivery. We often end up with overfetching data for mobile, or using patterns that just don't work on mobile, right? So let's try to avoid this. Then on the service side, we need to be prepared to deliver different content per platform, per version, and also to deal with different versions being live at the same time. So backward compatibility, always make sure we have that. Then to scale the resources management, right? And on the application side, the app needs to be prepared to do some sort of minimal functionality in void, so without any services being available, and to do mobile delivery at scale. So usually when we build a platform for mobile remote config and control, we try to at least have these things, like a way to turn features on and off, right? A way to control the text, a way to control the screen flows, such as the order or hiding some of them, but also a way to build a more structured UI, right? To control remotely the iconography, typography, align things, usually between different platforms, right? And so we need a configuration system, a good configuration system, and we sometimes may end up building our own because the configuration systems out there have some limitations. When we scale up, those limitations may no longer work for us. And to start building a structured UI environment could start with design tokens or styles or rules, and it has to be an API service. And obviously, when we build over this, again, I want to emphasize on the good collaboration skills between cross-functional here. So it's just not mobile devs. It needs to have really strong collaboration with the product side, with the design side, and the services side. So this would give us, the best chance to control live updates. And, beyond control to pushing updates, for that critical production bug or that new feature, as I said, we can go the OTA or code push way, which appears to be instant, but that's not really true. It has to be coded in, plus it's really specific to the platform solution you are trying to build, and the store update, which, we're afraid of it because of the wait time. But my opinion on this one is that right now in the mobile ecosystem, the delay is no longer on the store update. The delay has started to appear because of bad CI/CD setup. So if you have a good CI/CD setup in place, you respect the guidelines for the stores, and your team develops into a cadence, you are able to produce that candidate build with a better confidence, and then the only thing that limits you is that store update, which now could only take minutes to hours. So we're almost done. Time for some main takeaways. So right now, hopefully after this talk, when you consider mobile engineering, I hope we have understood the complexity and have cured a little bit of that UI-based tunnel vision. We have understood that it's really important to choose the right platform solution, but most importantly, how to evolve from that first release to a completely new product, or to respond to the disruptiveness of the environment. We have grasped the true dimension of mobile, and maybe we have relieved a little bit of that anxiety related to navigating updates. So that's it. Thank you very much.